Good afternoon. It's afternoon where I am, so not too sure if it is where you are. But today we're just going to do a little short video on secure shell. It's a way of a PC to remote into another device. Actually, if you've got Linux boxes, they will run secure shell by default, so you can remote in to those boxes. But routers and switches is what we're playing with. So we want to remote in, but a bit more securely than Telnet. Telnet is completely unencrypted, and secure shell is encrypted. Bit of a key exchange thing going on. So far more secure option for us to play with, and we're going to go through some basic configs of that. Okay, so let's pop onto this router up here, so you can see our network 192.168.10 is our broadcast domain in there, and 10.254 is this router. Now the same will happen for switches as well, and we'll remote in from one of these PCs down the bottom. Okay, so we'll pop onto our router there. So we're on router 1, type enable. Doing well, aren't I? And class, and let's put in the normal stuff that you have to have for secure shell to work. Okay, now we've already got a host name in there, so you have to have that. That has to change. The other thing that we have to add to our device in order for secure shell to work is a domain name. So IP domain name, we're actually giving the device a domain name. So if we go r1.bob.com, if that's our domain name, this is router 1 on bob.com, so it's a fully qualified domain name, and we have now added a domain name to this device. So we've got host name as r1, and we've actually added the domain name r1.bob.com, so fully qualified actually is r1.r1.bob.com if you really want to get pedantic about it all. We also need a username, so username, and we're just going to use a local database for this to start. Later on you can use a radius server or something like that. If we type in username here and add a whole bunch of them, then they are local to this device, which is not good for an enterprise level network where you need it accessible for everyone. So let's have a username called Stan. Let's change it up a bit. And in this username I can do two things in here. I can put a secret, or I can give a privilege level, and I'm going to go privilege. Now there's 15 or 16 actually different privilege levels that we can have, and 15 is the highest, which is effectively root access, so full access to everything. If you put in privilege 7, that's great, it'll work, but not work. The command should work, but the privilege level 7 hasn't been created. So later on when you play with security, you can create your own privilege level and give, say, level 7 certain rights on your router or on your switch or other places. So if you are getting stuck into it that way, go for it, but in our case we're just going to put a privilege 15 in here, and later on you'll see that we actually bypass a couple of things, so I'll come back to that. And then we put a password. So our user is going to be called Stan, and our password, let's put in Cisco123. So it's a bit different to what we've had before. Okay, so far we've done three things: hostname, domain name for the device, and a username. So now we need to enable secure shell on our device. So we'll go in, and we're using crypto, so cryptography. So crypto RSA, hang on, sorry, just got it wrong there. Crypto key RSA, and I really got it wrong, haven't I? Crypto, no, that's where it is, C-R-Y, crypto key RSA, truly? What have I forgotten here? Oh, sweetness. Crypto key generate RSA. It's a bit sad, wasn't it? Now, on physical devices, you can type in modulus and 1024, and what that means, out of all this, we're going to use cryptography. We're going to generate a key, and it's going to follow the RSA key exchange methods. Now the modulus says we're going to use a 1024 bit key. Unfortunately for us, this won't work in packet tracer, so let's get rid of our modulus 1024, and we'll just do the RSA bit. Hit enter there, and then it asks us what size modulus do we want. So by default 512. So at this point let's put in 1024 bits for our keys, which is incredibly secure. It's probably only 10 years ago that the US didn't allow manufacturers to actually have a key of that length, because they're quite hard to crack. So 1024, and it's generated our 1024-bit RSA keys. All good. The other thing we'll notice, secure shell has been enabled, version 1.99. You can go for nope, got it wrong. Change it to version 2, but we're not going to worry about that too much at the moment. It's actually, why not? Let's do it. IP SSH version 2. So a little bit more secure than 1.99. So we've created our key exchange. We've set up everything except for our line. So let's just have a look at our line ends, so the VTY lines. So what we're going to do is show our running config, and here's our username. Actually, just a little bit up, hostname. Username is in there, and on physical devices you might actually get the whole key listed up in there as well. IP domain name, don't confuse it with domain lookup, it is a different thing. And anyway, right down the bottom here we've got our line VTY 0 to 4, and we now want people to be able to log in to this using the local user account. So we've got this password that we put on a while back. We've got logging synchronous, so it's got nothing to do with this in a way, and we've login is there. So when we use telnet, we will use this password, which was Cisco, and login says use this local password option. Same for both that line VTY04 and line VTY5 to 15. So let's change this. So line VTY0 to 15, and we're going to put login local. So that says use a local database, i.e. the one user we've got, Stan, and log in to this device. Now the other thing we need to change, by default in Packet Tracer we're using telnet as our transport input, but let's change our transport input to secure shell. That says we can have all of them, we can have none, which will deny any protocol coming in, we can have secure shell, and we can have telnet. Now you can have both. It doesn't show it in Packet Tracer, but again on physical devices you can have transport input SSH and telnet, or telnet and SSH. So it will accept both, amongst other different types of inputs. So there it is. That should be it ready to go. So if we show running config here, things we've done, we've added a hostname. We've actually got an enable password in there as well. We've got a username, which is going to be used because it's login local on our VTY lines. And back up there, we've got a domain name. All the other stuff is the same, but what we've done is changed our bit down here to login local, and put our transport input SSH there for these BTY lines. So this password that we had in before is now redundant. We don't actually need that in there anymore. Okay, so let's see if this actually works. So we'll go into our desktop, and we need to run a command prompt. I'm not too sure if you can see that actually. Anyway, we'll give it a go. So, a bit awkward in Windows generally. You'll have to add an application that supports Secure Shell if you run it from a command line in Windows, and this is implied in the C drive here. If you run Linux, you can just go straight in and type in what it is that you want, and pretty sure that's correct. Okay, so what have I typed in there? So if I was on Linux, this is what I would type in. So SSH, use the SSH program, -L, it's not a 1, it's an L, and the username is Stan, and this is the address of the device I want to hit. And I'll just hit enter there, and it says open, good. Our password is Cisco123, and boom, straight in. Just notice that I'm straight into privilege exec mode. Because I gave myself privilege 15, sometimes if you don't put privilege 15 on a username, you will be asked at the user mode prompt. But in this case, we put privilege 15, and we've gained direct access to privilege exec mode, which is nice. Now, on a Windows machine, if you do not have SSH installed, you can use a Linux machine. That's fine, same command, or use something like Putty or Terraterm. They have SSH enabled into the apps, and it's a far cleaner and simpler way to go into it. So there it is. We have accessed our device, that device up there, from this PC remotely and encryptedly, so it's far more secure than Telnet. So yeah, done. That's about it really. Quite easy to set up, and works quite happily. Actually, I might just add a couple of extra little bits and pieces as I'm thinking about it. We'll do it from in here, right? So let's go into our line BTY 0 to 15, so 16 concurrent lines. We'll put a little question mark in there, and there's a bunch of stuff in there. There's message A banners and other stuff. If you wanted to put a access control list onto this line, we can go in via access class. So if you want to control your access even further to only allow certain PCs or certain network ranges to access this BTY, the same for Telnet as SSH, you can put an ACL on that. So access class would be it. The other one to secure up a bit is this exec timeout. So let's pop in and do that one. So exec timeout will say what's going to be our timeout in minutes, which means how many minutes of inaction should we play with, and I'll say 1 minute of not typing anything in before this connection dumps us out, because you don't want your connection left open forever in a day. And the next bit is how long is the timer going to be with inaction, so how many seconds actually. So the first one, I don't know if you noticed, is in minutes. I said 1 minute there, and how long are we going to dump us out for in seconds? So I don't know, what's a minute? 60 seconds. So let's do that. So that should, if I don't type anything in there for a minute, should dump us. So try that when you get home. Try it when you're playing around with the devices. See that it works, and time it, and go from there. And I think that should do us. So thank you for listening. Nice and short. Cheers.